So welcome everybody, please take a seat. We are starting with the lightning talk session on business/machine learning. A few unfortunate rules because we are under a very strict time limit. So first of all, if there is still a speaker here in the room, please come to the front row right now. Otherwise we're going to start now. There's a time limit of 5 minutes for each talk, and the slide set is going to advance automatically every 20 seconds, right? So for the speakers, there are a couple of rules. Please do not touch the PC. You have to align yourself to your auto-running talk. And I was told that you should not be too afraid of the microphone, so please directly speak into the mic. Unfortunately, we can also not really allow questions, so if you have questions, please ask the speakers either during the dinner or some other time offline, okay? I guess we can start now, so maybe shall I start or Control L? You will, okay, great. Then let's start. And speakers, please, I will not introduce you, so here's a general welcome to each of you. If you want to introduce yourself, don't do it too lengthily, it will cut into your time, but just introduce your talk and yourselves in any manner you wish to. Good luck.
Ready? Thank you. Yeah, I will do it anyway. So, hi, so I'm Martin, and today I'm talking about R in a small-sized bank's risk management environment. So why am I talking about this topic? So first of all, I've been working for various small banks for more than 8 years in risk management. And second, I'm an R enthusiast since my first days at university. And I'm a proud father of a 7-month-old daughter, which is why I only had time to prepare a 5-minute talk. I'm currently working for the Western Union International Bank, a small bank located in Vienna and being a wholly owned subsidiary of Western Union, best known for the money transfer business. So why do I want to use R in risk management? Simply to be more efficient, save costs, and just work better. And I will illustrate you how we can achieve that. So a traditional setup of a risk management environment often refers to Excel sheets being manually prepared or working in data silos, which leads to 3 major constraints: limited resources, regulatory pressure, and high cost of integration. So what else can we do? Integrate R. So the heart not only symbolizes my love and affection for R and Shiny, but also shows that R can be integrated as the center and main component of a risk management framework. There are many applications where you can use it in risk management, and one would be the automation of reports. So there are many packages specifically designed to connect R with other third-party tools, as well as packages just designed to scrape data from the web or other sources. Regardless of this classification, R can either exchange data with one tool and act as kind of a calculator, or act as a data intermediary. Here I have some examples how we use it in our bank. So one would be the development of an input database for our rating model. There we connect Salesforce using the R4Com package and a credit application tool using the HDTR package to load the data into a common database. Another application is the margin call process, a process done almost completely manually until now. Now we use BoxR and ReadXL to load the data automatically into R, and there we are generating automatic emails and Excel sheets with OpenX LSX and RDCOM client package. We can also use these connections by working with Shiny. So we have a value-at risk tool for FX derivatives where we're using the Quandl package that get market data from the same named website, and we're using the DBI package to store the data in a database. So as a next example, or in addition to the automation of reports, R can be also very useful when working with risk modeling. So I'm not talking about the modeling part per se, where R is a standard for quite some time, but about a whole project where friction between different systems and tools can lead to higher costs and inefficiencies. So a better way of doing it is to use R as a one-stop shop. So basically doing the whole process flow in R or in the R environment by ourselves, so basically the risk management, and redefining our job description as an end-to-end process developer. So I have a perfect example from our bank, which is our rating process. So we start by using R to develop a state-of-the-art rating model, then putting everything in a Shiny application for our users to use it, and then store the results by using the dplyr package. On the next slide, you will see that we're using the R Markdown package to document the whole process, and we're also using the Shiny dashboard functionality to create monitoring systems for our decision makers. Lastly, we're sending results back to R to validate and calibrate the results, and this improves our process a lot. So now let's talk about communication. The reports in R are often scary for users, especially not used to R, and there are many in the banking industry. So a better way of doing it is using Shiny as a front end with R in the back to get results fast and in a Shiny way. We also have an example in our bank with our ICAP tool we built in Shiny, where actually the stakeholders can get the results they were exactly looking for, and in an easy, understandable way. So we also don't need to transfer those results to other systems. So thank you. Thank you for your time. Many thanks to Goran Lovic, the head of our department, who was working with me on this project. And last but not least, a big shout out to the whole R community, also sitting here, for the big support and answering my stupid questions on the web.
Okay, I'll just use this time. I'm Chirag. I will be introducing the event studies package in R. And so I think everybody is aware of people who are working in finance, specifically aware of conducting an event study. You analyze the impact of an event on a given time series. So we've built this package which does this fairly easily. So it allows you to conduct event study, simple event study, and advanced research in event studies, which means that you can implement your own methodology based on the package APIs. All it requires is familiarity with Zoo. It automatically handles event time, so you don't have to deal with T+1, T-2. It converts continuous time series into event time for each of the time frames. And then it is generic enough because of its base in Zoo that it can handle intraday data or any data frequency. We provide 4 estimation models which are built in right now: the regular market model, the augmented market model, Patnaik, Shah, and Singh, the excess returns, and the constant mean return model. Then we have 2 cumulative abnormal return calculator functions. One is for sum with remapping and cumulative product with remapping. Okay. Okay, and we have 3 inference procedures built in, which is the bootstrap methodologies, which uses the boot method. Then we have the classic t-test and the Wilcox sign test. So you can take your data and use any of these inference procedure to compute the confidence bands. These are the steps which are done by the event study with function, which is the primary function of our package. It defines the event period. It converts physical time into event time. It defines the estimation period. It performs model estimation, and then it computes the cars. Then it performs inference test to compute the confidence bands, and then you can plot it directly. So this is one of the examples which uses chalk splits data on firm returns. This data is available in the package. The simple call requires only 4 arguments. You just define the data sets and the event window, and you mentioned the type of inference you want to use. In this case, it was none, and this is what the result is. It returns the response series and the outcomes, which you will see in the next slide. So the result is the confidence band and the mean which you can see in the second column. And then below you can see that there were only 5 successful outcomes of the 22 events, because whether the data was missing, whether the firm was not there, so you can you might have a big event list, but you may not have all the data in the data sets. And this is the plot, the mean series in the dark blue line and the confidence bands around it. And because it's an ES class, so it does the plot automatically. So I will explain the second. So the same data set, and with the second, we use a market model here. It uses the full argument list of the event study function. You specify the market model, you give it, you tell the inference strategy to use, and then you provide the market returns. So it'll perform a linear regression and use the market model. And then you plot it. So the confidence bands are tighter in this one, as against when we did not use any model. They don't look because the y-axis scale is different, but well, they are tighter in this way. So the package, we recently released the 1.2 version of the package. It's available on CRAN. You can install it using install.packages or DevTools install_GitHub. We do all the development on GitHub. Please feel free to report any bugs there. The man pages we've spent a lot of time in improving our documentation. We've tried to include all the inner workings of the function, so that just to build user trust. And one of the vignettes actually replicates to journal papers using the package function. Okay, thank you.
Okay, I guess I will give myself a few extra seconds and introduce myself. My name is Erin Liddell, and I work at a company called H2O AI, which is located in the San Francisco Bay Area. And I guess I don't have anything else to introduce other than my background is in statistics. I have a PhD in biostatistics, actually, and I've worked at a bunch of startups in the Bay Area as a data scientist, and now my title is machine learning scientist, which I'm not sure if there's a big difference. But okay, so H2O, I'm not sure if you've all heard of H2O, so I'll just say a little bit about what the company is and then what the software is. So H2O, the company is, oops, okay. So it's a company the company was started in order to put out open source machine learning software that's distributed for big data. So that's the whole point of it. It's been open source since the beginning, and yeah, so this is the agenda, which, there we go, okay. So we're gonna talk first about what is automatic machine learning. So this is kind of a high level slide saying all the things I think that are relevant to the automatic machine learning space. So data pre-processing is a big part of that. Model generation. So when you wanna do automatic machine learning, you wanna essentially generate a lot of models and then either ensemble them or choose the best one at the end. And then, yeah, the last point is ensembles. That's a part of the type of automatic machine learning I'm going to talk about today. And so in terms of, this slide is actually up for 2 iterations, so I have 40 seconds. So here's basically what I'm going to show you in the software today. So from data pre-processing, we do automatic imputation, one-hot encoding, and standardization. That's actually part of all of our H2O algorithms. And then for model generation, right now we have random grid search. And so we've pre-specified a sort of our own, what we think is a good hyperparameter space for each of our algorithms. And then we generate a large grid of models. And then we combine that with stacked ensembles. So there's a method called stacking or superlearning, which is you just give it a bunch of models. They could be good or they could be bad. And stacking will learn the best combination of those models and form an ensemble. So it's different than averaging or something like that. So it actually uses machine learning to learn what the best combination is. And ensembles perform well if the models are diverse and strong. And so this is one sort of reason why we do random grid is because you automatically get a very random sample. So, so the H2O, all of the H2O algorithms are actually written in Java and they're distributed, but we have an R package and a Python package and a GUI and a Scala API, and then you can of course use Java as well. So you would just get that from CRAN. It's called H2O. So in AutoML, what do? We do the pre-processing. We train a random grid of all these different types of models using a hand-picked parameter space. And then each of the individual models are tuned on a validation set. And then we ensemble them together. So this is the interface, essentially. So H2O, you just load the library, and then the first thing you do with H2O is you initialize an H2O cluster. And so this could be on your laptop. It would create a little mini cluster, or you can do this on Amazon or a big cluster with multiple nodes. And so that just starts up this Java process, and then you just proceed as usual. So we have our own import command. This is essentially read CSV, but just a parallelized distributed version. And then the function is called AutoML, H2O AutoML, and you essentially say what your training set is, what your response column is, and how long you want it to run for. You can also say how many models you want it to train. And then it produces what we call a leaderboard. We sort of borrow that name from Kaggle. And so it ranks all the models, and you see on this slide, the stacked ensemble, if you can read, is at the top. That's generally the best performing model if you compare to the individual models. And so that's what you get back, a list of models. They're all sitting on your machine, and then you can either use the ensemble model or any of the individual models that you want. And so here's the resources. This is not in our CRAN version right now, so you have to go to the download page, h2o.ai/download, and we produce a new version nightly. So this would be on the nightly release, and you click on it, and there's a install.packages command that has the link for our nightly release on there. So thank you.
Hello, my name is Reinhold. I want to introduce you a little bit to the upcoming usage of R in the pharmaceutical industry. I'm working in a big Swiss pharma business, and some of the problems we face there are different from other industries, I think. I have no doubt that R is going to make inroads into the pharma business, basically driven by the new generation of new hires, mostly statisticians, but also analysts of all kind. They got trained at the university in R. We have the R Studio, efficient integrated development environment, and Shiny, which is loved by management. And I'm sitting there and try to think of ways to speed up the uptake, because big companies move slowly. And besides just thinking of the technical environment, which is important, we also have other things to think. But first, the technical environment. We provide installation guidance and documentation for people to want to install R in R Studio, etc. on their desktops. But we also have a reference installation on a big server or biggish server. That is for the easiest access to that. Further, we stress the importance of using version control or source code management. So we have a Git repository server, and that is one of the big things to get people to use it. Further, a package server, because we try to push our users. If you have something that must be used more than once, make a package of it. But that is not all. There's also a social component to the R environment. Most important, communication, because we are so distributed over continents, but also you need local user groups. The local contact is important, we think. Training, similarly, very good is when you can give it to users that they can, at their own pace, do electronic courses, but that's not for everybody. We try to also have these local classroom events best on our computing environment. So looking at that, we have technical enablers. I think we have a good attack on that. We have social enablers, but that's not all. And this is, I think, what everybody in the pharma industry will point you to. That is a big, big problem there. Open source is very new there. It's a regulated industry, because in the end, if computation is wrong, in the extreme case, it might cause death or other physical harm to people. So the health authorities mandate computer system validation, which boils down to some documentary evidence that something has to be as specified. And that is now my point of it. I want to invite people to open source sense, collaborate across the different industry to define accepted set of standard R configurations that we all can use from. And one of the best candidates talking in our company was the Tidyverse Docker image from, because it provides all the things that you normally need for data wrangling. And on a case-by-case basis, you can add whatever you need on statistical tools on top of that. For that, we have set up a Slack channel, openpharma.slack.com. And for whatever we might produce in the end, we have an open source, an open pharma GitHub organization, and feel free to contact me via that and do contributions. I hope that this will help us and the patients in the future the best. Thank you.
My name is Mariana Simons from Philips Research, and today I'm presenting a work together with our clinical collaborators from Partners Healthcare in Boston, Massachusetts. So I want to present for you what we okay, the slides are coming. Just to tell you that I want to share with you how we use in Philips Research R actually to perform a healthcare cost analysis of our joint population. And these are elderly patients who are using the personal emergency response service. You know, my presentation is giving me a bonus time, which I appreciate very much. So you see now the title. And just to tell you that the Philips Lifeline Pulse service is actually a call button, help button, worn like a pendant, and which gives possibility of the patient to connect to the Philips call center in case of emergency. And actually the objective of this study were to analyze the healthcare utilization and the corresponding healthcare cost of these particular patients. We identified 3,335 patients which are getting care from Partners Healthcare and are Philips Lifeline subscribers. And the data source we analyzed were a combination of EHR data, financial claims, and Lifeline medical alert data over 5 years period of time, actually. And it's well known that in the Medicare population, the healthcare costs are very, very concentrated into the top 5%, the top segment of the cost acuity pyramid. And those patients incur 50% of all the healthcare costs. And our primary question was, is this segment the most expensive for our particular population? We performed a linear regression analysis, and we figured out actually that the cost of our patients are doubling in this 5 years period. And the major contributor to this doubling of the cost is not the top segment, but this is the M segment. You see the yellow line actually with the steepest slope, which is driving all the total healthcare costs. So there was definitely a need for management of the cost of the middle segments of the patient. And this is where we concentrated and gave a message to our businesses. Let's look at then into this cost acuity pyramid and try to model the flows of this patient through the segment of the cost acuity pyramid. And how we did actually this, we started with performing a Markov model, and the result of it, you see it on this slide. This is the resulting Markov chain and the transition matrix. And usually this is the way how I present the results always to data scientists, but to our management, we use a slightly different way to present these results. You see it on the next slide, the top panel. In summary, the top segment of the cost acuity pyramid is the most dynamic one. Only 1/4 of the patients are staying in the same segment next year, and 3/4 are going down to the bottom segments. And if we look into the cost flow, which is the bottom part of this slide, you see actually that the cost savings by the top segments could be completely phased out by the increase of the cost in the bottom segment. So this is actually one of our first findings where we figured out just looking into the top of the pyramid might be not enough. We have to look deeper. And actually, after quantifying the patient's flow, we were in position to combine all these flows and to identify who are the patients moving up or down the cost acuity pyramid. And we figured out that 18% of the patients are moving up on a yearly base, 20% of the patients are moving down, and 60% of the patients are staying in the same corresponding segments. So with this, I want to move slowly to the conclusions, actually, of our study. And while healthcare organizations are really focusing on the top segment of the cost acuity pyramid, this study discovers that there are very much potential cost savings in the lower segments of the cost acuity pyramid by identifying patients who are moving up to the top year by year. And we are now involved in a clinical trial which exactly investigates these movements and tries to figure out the cost reductions for these particular patients. Thank you so much for your attention.
Okay. Hi, my name is Anne Christoffersen, and I'm from Vestas Wind Systems. And you probably don't know what Vestas Wind Systems is, but in a short moment you'll see. Yeah, so as you can see, we're a wind turbine manufacturer, but also we are a wind turbine service provider, so basically providing customers the service of servicing and maintaining their wind turbines. I'll show you a case study on how we deliver cost models for the service sales departments. So basically, the goal was to make these cost models for maintenance of wind turbines, making the models readily available for the sales teams, and have them reviewed by subject matter experts. Constraints, existing Excel front end, and offline functionality. So besides that, we wanted to achieve other requirements. For example, effective collaboration between our global teams situated in Denmark and India. We did that using Git and GitLab discussion boards. We wanted a maximum level of reproducibility and reusability of our code, so we used R and made our own packages. We wanted to properly document the analysis, and we are using Markdown for all analysis. And then, you know, when the next yearly release comes up, we have the models from last year where you can start off. We also wanted to test, and we're using GitLab and continuous integration for that. So basically, the modeling processes, we extract data from the SQL server, model with R, make the review by the subject matter experts. Then we save our final models inside the markdown, and then the markdown is saved in a specific Git or a folder. Then, when we release, we run all the markdowns again, and then we collect the final models I'll show you in a moment. Then we package these models down into a separate package, make impact calculations, review with sales, who approves it before the models go to be distributed to the end users. So basically here, what you see is we have this folder in Git where we have all our markdown files. In each of these files, we have a command that basically generates VRDS files, which is just a Vestas RDS file with the model itself, the final model. So when you release it, you run all these markdown files, and then you collect all these .vrds files, which you then package in a, you can say, model container that you put into a package. So then your package have all your models that you need. Just to show you a little of the code when the slides change. Here, you can see a little of the code, but basically you can see you have the save RDS statements, and you can see in the file name that it's just called .vrds, so we can distinguish them before the input data files, .rds files. Then, in the second, you'll see the code here, which is basically running all the markdowns. So we are using the system command and then just running a new R script for each of the markdowns using knitr. And then, we had some, for continuous integration reasons, you have a try catch and a little more things there. So basically you see we have the data. We put aggregated version into Git with the markdown, so we can easily produce a PDF report and reproducible analytics. We share it with the subject matter experts, and that's all stored in the same, you could say, Git repository. Then we run all the markdowns in these libraries and fetches all these models, which are the final models, package them together with interface and forecasting functions into one big package with models, interface functions, and forecasting functions. Then we do some continuous integration with GitLab and Docker, where we test and make some forecasts to see if the output are okay. We build and release the R package, including these models. Then, because we have this offline functionality, we actually, push it to the end users, and then we have a .NET wrapper, so Excel can talk to our R package. We had several challenges. First of all, we didn't know R back in then. We didn't know Git, Docker, continuous integration, so we jumped all in, including the IT boat with version control testing and all that. So basically, it was going from ad hoc, problem-solving analytics to reproducibility. And it's in production, and we're delivering models to sales. It's reproducible, it's documented, and it's pretty easy to actually, change the model. So for the yearly releases, or if we find a bug, it's pretty easy to put in new models. And now we're making the second version. So thanks.
I'm going to make you wait a little bit before I start. You guys keeping warm out there? Yeah. All right, this will be a nice lead into the end of the afternoon. As far as I can see, there's no next speaker on the chair next to mine. So. Yeah, so a nice lead into the afternoon. I'm going to be talking about brewing beer, specifically about how I helped the company get a little bit more of an oversight of all the data they had. I'll lead into what that company is in just a moment. But yeah, it's a great follow-on from Melissa's talk on gluten-free biscuits. I assure you this is not about gluten-free beer though. That does exist though, and I've heard it tastes great, so not a problem if you need that. So here we have a classic picture of brewing. You often see these ingredients. You have the barley, you have the hops, you've got some water, you've got the final beer. But what's really missing here is the yeast, which is a critical part of any beer brewing process. This is just a little bit. This is my day job. If I didn't put this up, my boss said he wouldn't expense my beers. So yeah, this is where I work. We do open source consulting, big data consulting, helping our clients manage their data, understand their data, and get some commercial value out of their data. This is my dream job. I've got this little company called Dynamo Brews, which I do on the side, has absolutely nothing to do with Think Big. And that's me a couple of years ago delivering a couple of kegs of beer to some bars in Copenhagen. It's been a few years since I last brewed in a big scale. I think I'm losing my brewing credential. But here we are. This is the company that I helped. It's called White Labs. It's an American company based in San Diego. And I ran into them a couple of years ago, and I was able to start doing a little bit of consulting for them, kind of initially over a Skype link and a bit of emailing, that sort of thing. They now have an office in Copenhagen, actually, which has nothing to do with me. But this is where I ran into them. At that stage, they started having quite a bit of experimental brewing data, where they were brewing lots of different batches with different yeasts and trying to understand the effects that different brewing processes had interaction-wise with the yeast. And I met them at a beer festival, actually, the Copenhagen Beer Celebration back in 2012. Now, this was basically the form of the data, the kind of data that came out of the machines that they're using to analyze the beers. And I guess you can't really see, but I'll tell you, it's kind of a bit of an awkward mix of long and wide format data. It's kind of key value pairs, but also kind of different dimensions. That was the brew data that they had. This is the other half of the data, the recipe data. So within the brew data that we saw just a second ago, there was an ID to a certain recipe. This is supposedly the recipe that Barack Obama brewed when he had a bit of a home brewing sort of stint in the White House a couple of years ago. And yeah, this is what I produced. So now I'll just go through a couple of the views in the Shiny app that I made. Obviously, it's Shiny. And yeah, it just allowed them. It brought the data together. Up until now, before this point, they were able to compare one brew with one other brew, looking at it in Excel, and it was a very slow process. But here I gave them this plot or this facility where they can go in, they can plot data, they can choose different X and Y columns, they can choose to color their points by whatever they want to color, they can click on points. As you see on the bottom of this screen here, we've got the X and Y values of whatever's been plotted at the moment selected. This is after a click on one of the points. You can also drag an area and then you kind of zoom in on those areas. There's also some outlier detection going on a slidey scale. You can add linear trends, all that kind of thing. And this is all just stuff which to us is a simple process, and it's easy to do from our point of view with this little Shiny app. But for them, before, they just didn't have the tools to do it. An important thing is, it's not just to look at a pretty picture and that's that, but they also want to be able to export partly the data after they've done the filtering, but also export images for different kind of publications or just internal communications and that kind of thing. Yeah, so that was a very quick run through of that. Yeah, so this is the Bolmer peak. You may have heard of it, but it's the theory that there comes a point after a certain number of beers where programming comes out at its very best. And you can see it's after about 2 or 3 beers, I think, in my case. But this is just really to talk about the things that went well. I tried to stick as much as possible to kind of modular development in the Shiny app. Some of the things that didn't go so good or things that I would like to revisit is the data ingestion. At the moment, it's very quite hard-coded. I want to make it a little bit more flexible. I want to start using database connections and manage the connections using the pool package from our studio. And probably also try and get it into a slightly more formal kind of Dockerized environment. And yeah, this is the kind of the conclusion. I'm sort of stretching the truth a little bit, but I did work on some of the very early stages of this project, but this was something that the White Labs published a few years ago, where they're trying to look into the genetics of yeast and how that influences the way that our beer tastes in the end. That's that. Thank you.
So first biscuit, then beer, now candies. So are we in the food session or? So I'm going to scrap some seconds. Let me introduce myself. So I'm Xavi Guardiola. I'm a data scientist at King, as Rasmus Abad, who's here with me today. And we're going to talk about video games for a change. So how many of you, please raise your hand, how many of you have played Candy Crush Saga in your mobile game? Okay. So Candy Crush is probably our more famous game, but we do have other franchises like Bubble Witch or Farm Heroes. This is what we do. We do casual games. So games that you play on your mobile as a time filler while you are on a queue, on the bathroom, wherever. And basically these games are loved by some people. So we have like that amount of that amount of people playing every month. To give you an idea, that's basically more than people living in the US or more than people using Twitter. So as you can imagine, this amount of players generate an outrageous amount of information. So that's why King, being a very data-driven company, we have a bunch of data scientists, over 100, who are devoted, on top of the data engineers, who are devoted basically to make sense of all that data, analyzing the game, the data, and trying to improve the player experience and making games more fun. We are a kind of an agnostic company, so we let our data scientists choose their language or religion. So basically we're split within R and Python. But what I wanted to say today is how R has been so incredibly useful in our company, allowing us to do a lot of amazing things. So we are super happy with R. We actually have everything in place for new joiners to really adopt R, like having Docker images ready, R Studio servers ready so that they can be productive since day one. I wanted to basically mention three areas where R has been extremely useful for us. The first one, probably dealing with big data. So with such an amount of data, we always, of course, we can only store that into a Hadoop cluster. So we have developed some R packages internally, R packages to deal and access with this data. You know, on Hadoop, you typically on top of Hadoop you have Hive to do SQL queries. You could put Impala as well. So which by the way, Impala is awesome. I need to say that because it has decreased the time to run the queries by an order of magnitude. So we have developed some internal patches to access synchronously and asynchronously the data. King is very keen on open source, so we have released several open source things like Default, which is a really large game engine, but also in data we have started releasing things like Scylla. This is a query scheduler that did by one of my colleagues, Marco Cavizza. And yeah, so apart from access to big data, we also are producing a lot of dashboards. So the company has, you know, the typical sort of official tools. In our case, we use ClickView, we use Looker, we have several proprietary things. But you know, Shiny keeps creeping in the company. So you find Shiny stuff everywhere. And that's a beautiful thing to see. So we see Shiny apps deployed as just ad hoc dashboards just to prove some model and share it with some of your colleagues, up to really production-grade dashboards with all the bells and whistles, with HTML templates, custom JavaScript, and so on. Another area where R has helped us a lot is in reproducibility. So 3 years ago, we kickstarted an initiative called No Report Without Code, which may sound like trivial and evident from people from the academia, but it's not that common at least in the video game industry, I would say. And that basically means that, you know, every report, every analysis should come with a link to the GitHub code. So we basically have an internal GitHub where all our data scientists check in their work. And when we have to publish the work, we have several means, like sometimes we use IPython notebooks. You know, you can still run R in those notebooks. We use R Markdown and our Confluence wiki, which is basically our main. So we developed a lot of packages to make life easier for our data scientists so that they can easily upload the information in Confluence or their Markdowns or give you know, the King look and feel to the ggplots, for instance, right? So overall, we are super happy with R. I mean, I think it was a challenge because there's so many data scientists coming from so different backgrounds, and R has been like a lingua franca for all of us. So I think it's been a really good experience. And just a bit of spam, we are hiring again. Thank you.
After the beer presentation, I keep reading this banner as speaker hangover. I don't know why. by the way, from game to the use of game mechanics in interactive machine learning, especially to compute or estimate the cost of labeling data. So interactive machine learning is a kind of machine learning where users are kept in the training loop very tightly so that the user can give hints or suggestions to the algorithm in order to reach the goal much faster. There is an example of 2003 where there is a paper that contains the words interactive machine learning for the first time, where the segmentation algorithm, the image segmentation algorithm, exploits the sketches given by a user in order to distinguish a hand from the background. And that was the first time that it was demonstrated that this kind of approach works. Now you can find lots of systems that use this kind of approaches, that you can change features or examples and see interactively how your system is doing. Now the problem with this approach is that it's very boring. If you are the user, you do repetitive things over and over and over. So how do we keep the motivation of the user alive? So, and that's the idea of gamification. So think about this. As humans, we are competitive by nature. We like being rewarded, and we like to collect things such as the stickers from useR. Now you can use this to develop applications that takes this psychological thing into something that you do. So for example, you run faster than last week because the application tells you, okay, you're good, you're running faster. Or you write one more review on TripAdvisor because you get a badge, which is nothing. So how do we use this in machine learning? Now, just a tiny bit of example to draw the game. So if you use a binary classifier and use a Bayesian decision theory approach, you end up with this inequality, very simple, which gives you the optimal decision rule. Now, the nice thing about this inequality is that you can interpret the two likelihoods as the two coordinates of a Cartesian space and the inequality as the decision line. So we have elements. You have to buy label data to estimate the likelihoods, and you have to buy label data in order to adjust the line. And that's the game. So we have an objective. So we want to find the best line that fits the points or fits or separate the points. So that's an example. You have a data set and you color the points, and this is the game. Then you have actions. You can buy points. But then you have the game mechanics, and that's the difficult part. So we ended up with this idea of giving points if you assign or position the line better than others. Then we give some kind of rankings as in Poisson trees on the second floor. So we have a list of players. And then we give resources, a finite amount of resources. And I'll give you a hint of this in 40 seconds. So we designed 3 experiments. The first one was a prototype experiment. All of this kind, of course, is doing in Shiny with PhD students to have some feedback. And then we opened this application to the public in 2 public events in Italy. One with kids and the other one with general public. So with PhD, we designed an interface in a classic Shiny way where you have the controls on the left and the visualization in the center. Then the user could buy training and validation points with a finite amount of resources. And then they had a sort of, they could choose the line with sliders. Now, with non-PhD students, we devised this thing. So I give you a box of chocolate candies, and I say, okay, if you beat the baseline, the candies are yours. But beware of one thing. You cannot beat baseline if you don't buy resources or if you don't use resources. So they had to balance the fact that they wanted chocolate, but they had to spend some chocolate in order to reach the baseline. And that worked very, very well. So we played with kids, I don't know, for hours, and I was surprised because it's an abstract game, and I was surprised that people were playing this silly game, but they had chocolate, so they were happy. So at the end, what I can tell you is that people do not want to spend resources, even though they know they're going to lose, and that's surprising. But most important thing, at the end, on average, people spend 20% of the chocolate, which was 20% of the labeled data set, and we could build with just 20% a classifier as good as the same classifier trained on the whole data set. So you can think about it. If you have any part of your machine learning task that can be transformed into a game, think about it, because you can get labeled data for free and for fun. Thank you very much.
Hi, so I hate to disappoint you, but I'm not going to talk about games, and I have neither candy nor chocolate to share, but hopefully what I'm going to discuss will be of use in anything that you're doing. So my name is Raj. I work for a new startup in the US. I used to be with UBS, moved to a pharma company, developed a product, got a new investment, and a new startup was funded. I'm going to talk about the R KDB Plus interface. KDB Plus is a database used for high-frequency trading analytics in Wall Street, City of London. It's one of the least known but highest performing systems. Now, I've been using data.table for many years. I love data.table, but I've always wondered, is there a better way, a faster way of doing it twice as faster, thrice as faster? And it all started with APL. So APL is the Air programming language, came out in the 60s. It's a vector-oriented language. And it has some very nuances that I can't get into, but basically it's a way of expressing yourself through language in a natural way, a logical way of thinking. Ken Everson, he was in IBM, taught at Harvard. He won the Turing Prize Award for it in 1979. This sums it up, that language is an instrument of human reason, not merely a medium for expression of thought, is a truth generally admitted. There are concepts of verbs and adverbs, and people who have used functional programming with nomads and dyads will recognize what I'm talking about. So APL was very versatile, except it looked like that. And you needed a special keyboard. So it was a language built by mathematicians for mathematicians, just like R is by statisticians for statistics. Because it was so cryptic, only few people, like in London and places, would use it. But it was only in 1988, Arthur Whitney, who was at Morgan Stanley, developed A+. Now you could use a normal keyboard. 1993, KX Systems created K and then Q. There are certain factors about this that's very interesting. A, it's super fast. We all know that. We will get to know that. It does map reduce seamlessly. So anytime you run a query, it runs automatically. It stores data in columns. It's in memory plus on disk. One machine can be faster than multi-node AWS clusters. And the entire binary is only 500 kilobytes. 500 kilobytes, you can we start up like 15 terabyte databases on it in under like 2 or 3 seconds. The way you start it up is just /q, no installation, and it just runs. So I used the GitHub benchmarks for data.table as a reference, just to show the comparative timings of data.table, dplyr versus KDB+. And this is not a criticism of anything. I love all those packages. These are just some empirical results that I've been able to obtain. So these queries are non-trivial. If we have 1 billion rows, we're going to do sum across 1 billion rows, do aggregation across billions of values. So they would involve aggregation across 2 billion values, for example, to do a summation on 1 billion other values. So these are non-trivial, and thanks to data.table and these packages, we can still do them in R. So these are some of the comparative benchmarks. Data.table, some 1 billion integers grouped by one column of 1 billion characters. Data.table, 27 seconds. dplyr, 58, KDB plus 4. Some 1 billion integers grouped by 2 billion characters, 55, 144, 23. Like, I have never seen anything faster than data.table, so I was very happy when I started using this. But then there's a question, can we do better? KDB Plus does MapReduce, as I just mentioned to you. You don't need to write MapReduce code. So it's automatically parallelized for you whenever you run a very simple query, like a SQL query as an example. I thought, why don't we just put the data on disk? So now we're going to use the R KDB Plus interface. Some 1 billion integers grew by 1 billion characters, 511 milliseconds. Some 1 billion integers grew by 2 billion characters, 2 seconds. You can see the vast difference. Now, these have much broader implications. It means that your iterations run much more fast. It means that you can do cross-validations way, way more quickly, although it is not directly related to algorithms, but then the main premise of data.table dplyr is faster filtration, aggregation, and this solves that problem in a very elegant way. So I've often found doing things on my laptop has been faster than running it on our Oracle data warehouse ever since when we switched over to this. So I couldn't get into the mechanics of it, but you can download KDB Plus from that website. There's an R KDB Plus, which lets you interact with the database from R. Those are the links. I think the links will be posted. But more importantly, this is free for academic use. So if you're in academia, you'll get it for free. Wall Street buys that 500 kilobyte file for $5 million. Business applications, so technology is only so good to the extent you can make it work. It's worked very well for general purpose data mining, and because I moved into pharma, I just built a platform, and I think within a year's time we got enough investment to hire 15 people, and we're about to get 50 more people. And finally, I do want to mention, thanks to R and the KDB Plus community, R and the R community introduced me to a new world of data mining. KDB Plus allowed me to just take it to a new level, Dal, Srinivasan, and everyone else who's been very influential in the way I have looked at data mining in general. So I think that's it. Thank you.
So that concludes a very, very hot session. Let's maybe thank all of the speakers again and then cool down during the conference dinner.